Hi, students. I want to go over lab one, the homeostasis and graphing lab for you guys. So you can get started on that and then you actually know how to graph correctly. So for today's lab, you're going to do, record your body temperature. So you're going to take 10 measurements of your body temperature, of your own body temperature, and record those and then figure out your set point. And then you're going to do respiratory rate, and that's just counting your breaths per minute, right? And then your pulse rate, and your pulse rate is beats per minute. And so for pulse rate, you can count for 15 seconds and multiply that by 4 to get beats per 60 seconds. For respiratory rate, you can do 30 seconds times 2. And you need 10 measurements for each of these. And then you're going to figure out your set point for each of those. So this you can do at home. If you don't have a thermometer, then I'm not sure what to do. Send me an email if you don't have a thermometer and we'll deal with that. Okay, so then the lab that you're going to hand in is right here. So body temperature data, you're going to put your data right here. You can either write it in or type it in, and then you're going to figure out your set point using the mean, which is the average. So you're going to add all of the numbers up and then divide by 10. Then you're going to use your median to figure out your set point. And the median is the one that occurs in the middle. When you line them up from least to greatest. And then the last one is the mode. The mode is the one that occurs the most frequent. And so my question to you is, which set point is best to use, mean, median, or mode? I tell students this really depends on your data. So if your values for body temperature are all over the place and there's not one value that your body keeps coming back to, then it would be the mean. If there's a value that you see that your body keeps coming back to, or is a recurring value or the most frequent value, then your set point is your mode. And so really it's going to be between your mean or your mode, depending on what your data look like. We don't use a one in the middle because that is kind of arbitrary. And then you can answer the questions. Then I have you do a homeostatic feedback loop for body temperature. All right, so you can give me an increase or decrease in body temperature, and you should know both for lecture and lab. So we went over an increase in body temperature for lecture. You should be able to figure out a decrease in body temperature. So you might want to work on that and draw that out. And then confirm that it's correct with myself or one of the tutors, Richard, Diana, or Ernie. For summer, the tutors may be different for fall. So this could be an increase or decrease in body temperature, and then give me the sensor. Remember, it's going to be a receptor and give a location. And then the integrator, the effector, what did the effector do and what was the result. Then you're going to move on to respiratory data. So then you're going to figure out your set point and explain how you came up with that. Would you expect it to be different or similar from compared to a classmate? So find a classmate. If you already have a classmate in class, then ask them, or a friend in class, ask them. If not, maybe somebody who replied to your discussion thread, send them a quick little note to ask them if their set points were the same, and think about why that happened. And then answer the questions. And then the homeostatic feedback loop for respiratory rate is right here. Your stimulus or your mechanism to breathe is based on increase in CO2. And so I'm never going to ask increase in oxygen or drop in oxygen, because your mechanism to breathe is based off of accumulation of CO2 in your plasma. So I want you to give me a sensor and a location. Again, integrator, effector, response, and result. This one might be a little bit more complicated or difficult to find. That's okay. You can look up respiratory rate is going to be chemoreceptor reflex. And so look up chemoreceptor reflex and then see if you can actually fill this in on your own. If you have questions again, come to my office hours on Tuesday from 1 to 2, or send me an email or set up a time to Zoom. I don't expect this one, and I don't expect the heart rate one to be easy. It's something that you guys haven't seen before, and it's going to take a little bit of practice and time. So be patient with yourself. Um, I don't expect 100% perfection on the first day of class, right? So your pulse rate data goes here. What's your set point? Give me some physiological error values. Now remember, physiological error values does not mean that they are error, like wrong, like outliers, like as in math or chemistry. Physiological error values, this means it is it's physiological deviation or physiological variation. So really, we can put, you're going to figure out your set point and then give me values that are not your set point from the data that you just collected. All right, you should be able to know how to do this for an exam, and just generally speaking. So you always want to know normal range. So let me see if I can actually use the pen for this. I don't know if it'll let me do this on this document. So I want you guys to figure out what normal range is, right? No, it's not going to let me do that. I'll write it here. So make sure you know what normal range is. How many more times can I say it? For each of the homeostatic feedback loops. So you should know normal range for blood pressure, for heart rate, and for respiratory rate. Then know typically what a set point is, or how you would calculate a set point, and then how you would figure out physiological error from a data set. And I'll repeat this again. It means variation, right? Does it mean that it's wrong? No, it's just physiological variation. It's any number that's not your set point with your data set. I'll say that time and time again, and students will still get it wrong. So pay attention, okay? All right, and then fill in the chart for the pulse rate. I'll let you know, you guys, that this is going to be a barrow. Look under baroreceptor reflex, right? So your blood pressure and heart rate are regulated via baroreceptor. And that should help. For the last part, once you have all of your data collected, I want you to enter your heart rate set point on the discussion board and tell us what column you fit into. So for my heart rate, my set point for heart rate is 74 beats per minute, right? I exercise 3 or more times per week, right? So I get my heart rate up to, here's your criteria for all of you kinesiology or exercise phys people. How do I know if I get my heart rate up to 60% of max for half an hour? Figure out your maximum heart rate, 220 minus your age, then calculate 60% of that. How many times a week do you get that, your heart rate up to that? For me, I get it up to that 3 times a week. So I would put in the discussion board, 74 beats per minute is my set point, and I get my heart rate up to 3 times per week. All right. So once we have everybody posting their set point and what column they fit under into the discussion board, I want you guys to separate them into categories. I want you to separate them into 0 times per week, all the data points for 0 times per week, put all the data points that fit under that category 1 to 2 times per week, and then 3 or more times per week. And then you're going to average all of those values in each category to come up with an average number per category. I just realized that we needed to go over graphing and do this yesterday as I was reading through everything. So The discussion board isn't ideal. I thought maybe I could upload an Excel file and you could write on it, but I don't know how to do that, and I don't want to try to figure it out on the fly. The same thing with working with groups in Canvas. And so I think eventually I want to try the group, some type of group activity on Canvas, maybe for extra credit. But right now I want to get you guys started on the lecture and the lab, and I don't have extra time to try to figure out the group stuff. So if anybody is an expert at Canvas, or they've used a group setting to work in groups on Canvas, let me know if you don't mind. And I'll figure it out, and we'll figure this out together. Okay, so once you're finished with this, you're going to come up with an average for each grouping, right? And then we're going to graph it. But before we graph it, I want you to tell me what you predict will happen. So what do you predict will happen to a person's resting heart rate as their weekly exercise level increases? So if I was doing this, and again, this is a hypothesis or a prediction, and so it's a statement about what you believe is going to happen. So I predict that, and you can plagiarize this, right? And some of you may already know people in the class, or people have taken the class. If you work on labs together, I encourage you guys to work together on material, but I want to make sure that everything is in your own words. So don't hand in material that is the same wording as someone else, or the same wording as something that you found online or in my notes or handouts or what have you. Okay, so everything that you hand in or write or type needs to be in your own words, period. End of story. Anything else is considered cheating. Okay, so I predict that a person's resting heart rate will what? Decrease as their weekly exercise level increases. Okay, why do I think that? Well, the heart is a muscle, and the more you exercise that muscle, the more cardiovascularly fit it gets, or the better it gets, right? The more effective pump it is. So the more times you exercise, the more conditioning it is, and then the less beats per minute it has to do, because it's pumping out so much per beat, pumping out so much blood per beat, that it doesn't have to beat as much. So for example, my resting heart rate is 74 beats per minute, right? My husband, he's about the same body size as me, but his resting heart rate is around 36 to 40 beats per minute. And so his set point is 40 beats per minute. Why is it so low? He is a long distance runner, and his heart is so fit that it contracts with so much force that it doesn't have to beat as much as mine does. So I'm out of shape relatively compared to him. Okay, let's talk about graphing. So the last thing that you're going to do is you're going to make a graph of heart rate versus exercise level, and you're going to hand it in. And then you're going to interpret the graph. All right, so when you interpret the graph, please write in complete sentences. I want you to tell me if your results that you got for the class, or the results that we got for the class, match your predictions that you predicted just a second ago. All right, here's graph paper. It's not so great. If you have graph paper, that's great, use it. If you don't have graph paper, please download. You can look up free graph paper online. Do not use a notebook piece of paper. I want you to use actual graph paper, because you need to get comfortable with figuring out number lines and what have you. So if you have questions on graphing, please ask me. Okay, so I'm going to pause this, and then I'm going to stop this, and then I want to go over graphing with you guys. So I'm going to do it in another recording. Actually, maybe I'll just do it here. So let me see. I'm trying to figure out how I'm going to write on this. Oh, I know. Okay, so let's do, I'm going to share, but I'm going to share with a whiteboard. Okay, so let's see. Okay, so let's see. So let's figure out how to graph. I don't know where it shows me my colors. Okay, well, we'll just try this and figure it out as we go, right? So when you're dealing with data in science and just generally speaking, there are two types of data that you're going to come across, okay? The first type of data is discrete data, right? So discrete data, let's see if I can actually write this. Let's make it a little bit narrower. Sorry, you guys. Let's do the eraser. Okay, let's try it again. So there's discrete data and continuous data. Nope. Let's see. Let's see, I can make it smaller. There we go. Okay. So, sorry guys. Discrete data. There we go. Is that better? It's kind of messy, but at least you can see it now. So there's discrete data, which is data that fit into groups or category. Whoops. Into groups or categories. Okay. And then there's continuous data. These are data that continue to infinity. Kind of weird, right? Whoops. Go to infinity. To infinity and beyond. Okay, so if you have discrete data, you know that you have discrete data because it's data that fit into groups or categories, right? So an example of this would be male versus female, right? Or different ethnicities, different eye colors, different activity levels, hint, hint. If you have discrete data, you're going to make a bar graph, okay? What is a bar graph? You have variables, and each variable is represented by a bar, and then your number line is over here, right? Whatever that number line is. And so if you have discrete data, you know you have discrete data because they fit into categories. You're going to make a bar graph with that data. For continuous data are data that go on to infinity. So this would be any type of number line. A big one would be time, right? So anything versus time is going to be continuous data. So time, length, weight, etc. If we have continuous data, then you're going to make an XY scatter plot. And connect the dots, most likely. So it ends up being a line graph, okay? This is what an XY scatter plot looks like. So let's say this is, let's see, heart rate versus time. Then here's your heart rate, you start exercising, and then you come back down, right? And usually we connect the dots to make some type of a line graph. Okay, so notice how there's no pie charts, there's no three-dimensional graphs. This is it, right? And so for science, you have discrete data and continuous data. discrete data fit into groups or categories. If that's the case, you're going to make a bar graph, continuous data or data that continue to infinity. If you have that type of data, you're going to make an XY scatter plot. Okay, let's go on to talk about your X and Y axis. Okay, so when you're doing a graph, you have obviously two axes, right? You're going back to algebra. This is your x-axis, and you don't have to label it X and Y when you're drawing it, but just so for conversation, or so for clarity, we know what we're doing. Your x-axis is where your independent variable goes. And then the y-axis is where your dependent variable goes. All right. So how the heck do you figure out what is a dependent variable and what is an independent variable? In your experiment, in all experiments, there's a variable that you are changing. And in all experiments, there is a variable that you are measuring. The independent variable is the one that you're changing. The dependent variable is going to be the one that you're measuring. Okay, so if we're talking about heart rate versus activity level per week, which one is the one that we're changing? Are we changing heart rate? So is it 100 beats per minute, 102 beats per minute? Or are we changing the category, the exercise activity level? Good, so we're changing the activity level. So for this one, and I'm gonna erase it so we can see it better, or so I can actually label it appropriately. Okay, so activity level would go here, right? And then the unit of measurement is always going to go in parentheses because you need to tell readers what unit of measurement it was. So this would be times per week. Okay. What are our groupings? Good. So it's 0 times per week, 1 to 2 times per week, or 3 or more times per week, right? So that's the variable that we're changing. So that is our independent axis label, right? Then what is our dependent variable? So our dependent variable is the one that we're measuring, and that would have been heart rate set point. So heart rate set point is going to go here. So this would be average, right? Set point, and I'm going to abbreviate for heart rate so that I don't take up the whole thing. And what was the unit of measurement for heart rate? So the unit of measurement for heart rate is beats per minute. So beats per minute has to go in parentheses. So you're telling the reader what the unit of measurement was, okay? And I'm anticipating that we're not going to have anything lower than 50. So you can start your number line at 50 if you want to. It depends on what data you get. And you're going to put 2 hash marks to denote that, yes, this is 0, but you're going to start your number line at 50. So you can do 50. You can do it in increments of 5 if you want. It really depends on what the data look like. If you have issues graphing, when I was first learning how to graph, or when I was graphing on a regular basis, it was hard to figure out the number line or the increments. Stop by office hours or send me an email and I'll be glad to help. Or if you want me to check your graph before you hand it in for this lab, that's fine as well. And so let's say my 0 times per week were 75 beats per minute. So the average from the 0 time per week people was 75. right? And then 1 to 2 times per week was, let's say 65. And then for the 3 or more times per week, it was 55. And so what trend do you see? Good. So you see a decrease. Um, so as activity level increases, as you go from 0 times per week to 1 to 2 to 3 or more, the heart rate, the set point for your heart rate actually drops, right? So 0 times per week was 75, 1 to 2 times per week was 65, and then 3 or more was 55. And so the more times per week you exercise, the lower your resting heart rate is. This is what should happen. That isn't always what happens in a small setting like a class setting, because our sample size isn't that great. And so the idea behind data collection is the more samples, like the end value, or the more people you have, or the more data points you have, the closer you get to the actual value or the true value. So a sample size of 30 people isn't very strong, and you can't draw any conclusions from that. If I had 200 people, or maybe 10,000, 200,000 people, a million people, then what we're seeing in the data would closely reflect what actually is. So it's really interesting. And of course, this isn't statistically valid. We're not doing data analysis on this stuff. If you were in some of your upper level chemistry, upper level biology courses, or upper level nursing, you're going to learn how to do stats on all of this stuff. And so it's important to get comfortable with math and statistics. Okay, so now you know how to graph. When you are stuck graphing for the next labs in the future, please come back to this and look at your notes and figure out how to graph. And I expect that you will know how to graph for the lab exam. Okay, I'll talk to you soon. Let's see.